Okay. So let's start with our density and specific gravity. So first, let us discuss the relationship between temperature and density. So as the volume of an object increases with specific temperature, it is because of the matter's volumetric thermal expansion. So volume is not a constant measurement. Okay, if you measure a certain amount of gas or a certain amount of liquid at kinuha niyo yung kanilang volume, then you heat it up, it would actually expand. It's because thermal kinetics actually affect the movement of our atoms. So as more energy in the form of heat is introduced into the system, what happens is our liquid or our gas or our solid tends to expand. So in terms of density, this is important because the formula of our density is mass over volume. Mass does not usually change, okay? But volume does. So volume varies with temperature. And therefore, the density of a certain substance will change depending on the temperature. So our density changes with our temperature. Now the question being is how severe does the change of our density have, or gaano kalala ang paglilipat or pagbabago-bago ng density according to temperature. It depends on your substance. Okay? Substances might expand or contract differently responding to different temperatures. So as an example, water, which has a density of 1 at 4 degrees Celsius and around 0.9986 at 20. So, ganyan po kalala ang changes ng density. So, the small changes in temperature needs to be accounted because if we do not account for the small changes in temperature, we might have an inaccuracy in our final measurement. Or it might be more severe, in which you compound different inaccuracies, leading to a farther and farther result from the true value. So basically, the density of an object depends on its temperature. The higher the temperature it is, the lower the density. Okay? Why is it that the higher the temperature, the lower the density? Remember that volume and temp are directly correlated or directly related. As temp goes up, volume also goes up. And if the volume goes up, the density goes down because mass over volume equals density. Density is inversely related to volume. Okay, so that is the explanation why as temperature goes up, the volume also goes up and the density goes down. Mass is not affected by temperature. Okay, any questions? Okay. So even if we assume that water's density is 1 at 20 degrees Celsius, standard temperature and pressure is applied when determining the density of an object. I think this is 4. Ay, hindi. Tama. I'll double check later. So even if the water's density is 1 at 20 degrees Celsius, standard temperature and pressure is applied when determining the density of an object. The specific gravity is usually determined at 25 degrees Celsius. So this is a rule of thumb. Ideally, if you're going to conduct a measurement of our specific gravity, you should perform it at 25 degrees Celsius. However, it's not all the time it is feasible to do these measurements at 25 degrees Celsius. Take for example, sa laboratory natin, dalawang aircon natin, kahit pa dalawang aircon natin, minsan hindi nababa ng 24 ang temperature ng room or hindi nababa ng 28. So medyo mainit sa laboratory. So it's a little bit impractical to change the ambient temperature of where you are experimenting on. Okay? What instead is more practical is to get a table of known densities at different temperatures. So let's see if I could bring... Okay, as you can see, US to, pasensya na, US to. So they have stupid units. So kindly take a look at degrees Celsius and what is the equivalent of density. Okay, so take for example, the closest to 25 is this one. 21 is 0.9980, while at 4 degrees Celsius, it's exactly 1. Okay, so instead of controlling temperature when you are measuring the specific gravity of water, what you can do instead is to refer to a standard table like this one. Okay, so you have a wide range of densities present. Ito medyo kulang pa to eh. If you look at engineering references, mas madaming more specific and more accurate measurements of water density, especially if ikaw ay isang hydrologist. Okay, let's continue. So, specific gravity is usually determined at 25 degrees Celsius, but that is not always the case. In terms of alcohol measurement, it's determined at 15.56 degrees Celsius for alcohols. That's the usual way of determining specific gravity of alcohol, or ethanol for that matter. So we have different ways of determining specific gravity of our liquids. So the first one is our picnometer. Our picnometer is a glass flask with a tightly or close-fitting glass stopper with a capillary hole, so air bubbles may escape from the apparatus. The fine hole releases spare liquid after closing a top-filled picnometer and allows for obtaining a given volume of measured and or working liquid with high accuracy. Density determination is the most precise and most accurate method. So the best method of determining specific gravity is through our picnometer. So in our lab, I have demonstrated to you how to use a picnometer, the different parts of the picnometer, what are the steps in measuring density using a picnometer, di ba? Ang gulo-gulo pa nung araw na yun at tagilid yung camera. But at least nakita nyo kung paano gamitin ang picnometer. Picnometers may or may not have temperature scales like this one. Tanyo yung picnometer sa kanan, wala siyang thermometer. But I'm not sure if lahat ngayon ay naka-temperature as the stopper na. Nung bumibili kami, ito lang ang nakikita ng picnometer. Yung lagi siyang may thermometer na kasama. Okay? So, picnometer does not actually measure volume. The use of picnometer is actually to get the weight of a liquid. so that you can convert it into milliliters using its standard density. Okay, later I will be showing you the formula how to compute for specific gravity in liquids. The next method is our Mohr-Westphal balance. So this is what the Mohr-Westphal balance looks like. It is an older type of specific gravity balance using the Mohr-Westphal apparatus. The main advantage of the Mohr-Westphal balance is it is easy to set up and it is very easy to use provided that you calibrated it correctly. So it simply works by suspending a glass tube, this one. It works by suspending a glass tube into a sample of unknown density. Then a thin platinum wire balances the scale. So this is the scale with horseshoe weights. So depending on how many horseshoe weights you have used and how many or in which part of the scale you used is the method, is the calculations depending. Nagdedepende ang calculations natin kung ano kanya specific gravity. So sa lab, ituro naman ito sa inyo sa lab. Next method is our hydrometers. Hydrometers are instruments that measure specific gravity of liquids. It is usually made out of glass and consists of a cylindrical stem and bulb weighted with mercury or lead to make it float upright. The test sample is poured into the liquid until it floats freely. At that point, the surface of the liquid touches the stem of the hydrometer, correlates it to its specific gravity. Hydrometers usually contain a scale inside the stem so that the person can read the liquid's specific gravity. So how is a hydrometer used? Basically, you fill up a graduated cylinder with your liquid. You insert the hydrometer. Then it will float. Okay, it will float up and down depending on the specific gravity of the liquid, and you will read. So if you are looking at it upright like this one, you will read the scale in the hydrometer. So where the liquid is touching the scale, you are going to read it and it will give you density. So basically it's very practical. Simply place the hydrometer, look down, check the scale. Where the liquid or the top portion of the liquid is, you're going to look at it and check what is the reading. And you have your specific gravity. Okay, so this is a very fast way of using hydrometers. And one of the industries that mostly use these types of hydrometers is the alcohol making industry. If you're going to make beer, wine, or any alcoholic drink, you're going to use a special type of hydrometer called alcoholimeter. So instead of specific gravity, pag hinulog nyo yung hydrometer at tinignan nyo yung scale, hindi nyo makikita ang spec grab. Ang makikita nyo, percent alcohol. But it works on the same principle. So the principle of the hydrometer is based on Archimedes' principle that a solid suspended in a fluid is buoyed by a force equal to the weight of the fluid displaced by the submerged part of the suspended solid. Thus, the lower the density of the substance, the farther the hydrometer sinks. We have different types of hydrometers. First is our Boumet hydrometer. So our Boumet hydrometer was a skill developed by the French pharmacist Antoine Boumet to measure the density of various liquids. We have two general types: for liquids lighter than water and for liquids that are heavier than water. Like for example, crude oil for heavier than water. Then for lighter than water, you have your hexane and other solvents. So this is the Boumet scale. So this in particular is for liquids that are heavier than water. Next is a alcoholimeter, what I talked about earlier. So an alcoholimeter is a hydrometer that indicates the alcoholic strength of liquid. So you do not get specific gravity using this hydrometer. Instead, you're going to get percentage strength or proof, percent proof. So it is also known as proof and trails hydrometer, and alcoholimeters have scales marked with volume percentage of potential alcohol based on a pre-calculated specific gravity. So it also depends on specific gravity, but it is calibrated for percent alcohol. So this is our alcoholimeter scale. Okay, so hindi po spec grab ang makukuha nyo. Ang makukuha nyo po ay percent alcohol. Okay? So if nakalimutan ko siyang sabihin nung FARCAL, proof and percent alcohol, these are two common methods of describing strength of alcohols. So if you look at a bottle of gin, take for example, Cuatro Cantos or Bilog, you will see 80 proof. 80 proof does not mean 80% alcohol. It actually means 40% volume per volume alcohol. Or weight per weight. Volume per volume. Okay. So proof is simply twice percent alcohol. So this might come in useful if you're going to check which two alcoholic beverages is stronger, and the one is in percent alcohol, one is in proof. Simply divide proof by 2 and you will get percent alcohol. If you have percent alcohol and you want proof, simply multiply by 2. Okay, both is accepted naman. Next is your Fahrenheit hydrometer. It's not very modern, but it's still of historical importance. So for our Fahrenheit hydrometer, this is a constant volume device that will float in water, and you're going to place a set of weights on top of the scale until the hydrometer sinks down to the water line. At that point, you measure the weight of the water displaced. You also have your Nicholson hydrometer. It's similar to your Fahrenheit hydrometer, but has a basket for measuring specific gravities of heavy and light solids. So the difference of the Nicholson hydrometer is it can measure solids. Next is your specific gravity beads, or your rosary beads, or your Loewe beads. So these are used in operations where boiling liquid is to be evaporated until it has a specific gravity. So this has a practical use when manufacturing. It is also used to measure specific gravity when mixing liquids of different densities until a certain density is desired. So this is also known as your Loewe beads. And to use these, each bead actually corresponds to a specific gravity. Okay. So, ihuhulog nyo. Kukuha kayo. Ihuhulog nyo sa liquid. Then, you're going to check it if it floats or if it sinks. It's not a good method if you're going to determine specific gravity. But this is a good method if you're going to adjust specific gravity. Since dito baliktad. Alam mo yung specific gravity na hinulog mo. Hindi, may bead ka, hinulog mo. Alam mo yun yung target mo specific gravity. So habang naghahalo, it's either magdadagdag ka ng liquids or i-evaporate mo, ihintayin mong lumubog or lumutang. Okay? And doon nyo ma-determine if tama na yung inyong specific gravity. It depends on if the beads sink or float. Usually you use 2 at a time, 2 or more at a time. So parang may range ka ng specific gravity. Since usually in the manufacturing process, hindi naman required na very specific ang spec grav mo. You are always given a range of specific gravity. Okay? So again, low V beads, this is not used to determine specific gravity, but instead used when we are adjusting specific gravity. Another one is your hydrostatic balance. So here, a substance is immersed into the liquid with the aid of a weightless thread. The object is weighed down by a sinker, which is an insoluble, dense body with a known weight. So this is similar to our Moore-Westphal balance. So for specific gravity determination of solids, you have your graduated cylinder method, or you have your displacement method for solids. So direct measurement of the volume of the solid is based on the volume it displaces when it is immersed in a liquid. However, please take note, it is only used for small solids with a low specific gravity, and it is insoluble in liquid. You can also use the picnometer for determining specific gravity of solids. However, the caveat is it should be small fragments or fine powders, and it should be insoluble. Okay? You cannot determine the specific gravity of a soluble powder. Because at the moment you add liquid, it won't have its shape or its original form anymore. It will dissociate and combine into a solution. Also, it should be small enough that you can insert it into the mouth of the picnometer. Pwede mong durugin, pwede mong i-triturate para lang kumasya sa picnometer. Basta kasya sa butas na picnometer. Okay. So how do we determine the specific gravity of a liquid using the picnometer? I will give you 3 minutes. Kumuha kayo ng papel na malinis, at kumuha kayo ng ballpen, at kumuha kayo ng calculator. Okay, let's continue. Okay? So when we're going to determine specific gravity of a liquid, ang kailangan nyo is to measure the weight of the following. You need to get the weight of the empty picnometer. You need to fill the picnometer up. With water. Please take note that water is usually our standard liquid unless stated otherwise. You may use other standard liquids provided that you know the specific gravity of that liquid at your operating temperature. Naintindihan po ba? Naintindihan
Yes,
po?
sir.
Okay, so maalin siya sa water or sample liquid. Or, sorry, water or standard liquid. Okay, so mamaya kasi, baka mag-interchange ako between standard and water. They are the same. We can assume the same. Okay? And you should also get sample liquid together with your picnometer. Okay? If you have weighed the 3 values, empty picnometer, picnometer full of water, picnometer full of sample liquid, you're just going to input it into our formula. Our formula for spec graph is Picnometer plus sample liquid. Please take note na itong values na ito ay for my naming lang. Kumbaga isang buong variable to. Okay po ba? Baka kasi malito kayo na bakit pinag-a-add ni sir. It's not. It's simply a variable. I'm just spelling it out so it's clearer. Naintindihan po ba? So picnometer plus standard liquid, bago sa baba, you have, picnometer plus standard liquid minus weight of picnometer alone, empty picnometer. Then sa baba, picnometer plus standard liquid minus weight of picnometer. Then multiply it by spec graph of standard liquid at temp. Okay, nakopya po?
Yes po, sir. Okay.
Any questions so far?
Ano po?
Okay. Now, if you have a piece of paper, lagyan nyo na isang malaking bar, ganon. Susulat nyo yung alternative formula. Okay, you have an alternative formula. This is the spelled out formula na kompleto lahat ng details. But if you want a more compact formula, this is the more compact formula. Okay, so this is the same formula as earlier, but already computed. Okay, so yung kanina kasi buo yung formula. Okay. Mukhang hindi matatapos ang pagtahol ng aso ng kapitbahay. So, this one actually came from this one. Okay po, naintindihan po? And this one actually came from this one. Okay? We just have compacted the formula. But it is still the same computation. Naintindihan po ba?
Yes po, sir.
Yes po.
Yes po, sir.
Okay. So, let's have a sample problem. Sorry. So, ito pala yung explanation. So, in The main procedure of getting the picnometer, there's a specific order. Wait lang ha, sarado ko ng pinto. Okay, let's resume. Naayos ko na yung pinto. Okay, so the order of doing a picnometer measurement is first you get the weight of the picnometer. Once you have the weight of the picnometer, you're going to fill it with your distilled water or any standard liquid. And the volume of water that is filling the picnometer is this one. However, you can get it, but it's not actually being used in the formula. So the mass of the water is determined by subtracting the weight of the water plus picnometer minus the weight of the picnometer itself. We repeat the procedure for the liquid with an unknown density and determine its weight by using sample plus picnometer minus weight of picnometer. Since the picnometer accommodates the same amount of liquid, okay, yun yung main reason kung bakit magandang picnometer. Hindi magbabago yung capacity ng picnometer. Okay? If the picnometer was calibrated to 50 ml, it will occupy any liquid will occupy 50 ml provided that you place the liquid correctly. What do I mean by place the liquid correctly? Pupunuin yung picnometer, then isasara ninyo, aapaw. Sadya siyang aapaw, sadya kayo magkakalat. Aapaw, pupunasan nyo, then sure kayo na 50 ml yung laman ng picnometer. Calibrated yun doon. Okay? So since the picnometer accommodates the same amount of liquid, the sample's volume will be the same as the initial distilled water. So you can now directly compare the two liquids. And apply the density formula, mass over volume, and you will get the sample's density. Okay, so let's apply it in our first sample problem. I hope you have your paper with you and a calculator ready, and let's start with our first computation. Pero hindi ako gagamit ng calc, I'm gonna use Excel. Okay. So a student collected the following data in attempting to determine a density of an unknown liquid by the picnometer method. Determine the density of an unknown liquid using the standard liquid as water, and the density of water at 23 degrees Celsius is 0.9975. The mass of the picnometer is 32.4345. Mass of picnometer plus water is 58.0558, and mass of picnometer plus unknown liquid is 52.8734. Okay, solve it on your own, and I will solve it on my own as well, and let us compare our solutions. Okay, so kindly start. Sabayan tayo mag-solve para pag iba-ibang makuha natin sagot, we can compare our answers and see where we made our mistake. One is 52. Huwag niyong panoorin ha. Magsugat din kayo na inyo. Wala pong unit ng spec graph, ha? Spec graph ang makukuha niyo dyan. Tama kaya lumabas sa Excel ko? Yes. Okay, were you able to get the same answer?
Yes po.
Yes po.
Okay.
Yes po, sir.
Okay. Sige. If ang nakuha niyong sagot ay if ang nakuha niyong sagot ay 1.25, nagkabaliktad kayo ng formula. So, kung meron sa inyong 1.25 na nakuha, napagbaliktad nyo ang density ng liquid at, ang weight ng standard liquid at weight ng ating sample liquid. Sample is on the top portion of the formula while standard is on the bottom. Naintindihan po?
Yes po,
Yes
sir.
po.
Yes po, sir.
Okay, let's have another one. Okay. Okay. Wait. So the next one is for determination of solids. Okay. When we are going to determine the specific gravity of solids, we are now going to use additional variables. Okay. So a student collected the following data in attempting to determine the density of an unknown solid by the picnometer method, which used the immersion liquid as ethanol. Determine the density of the unknown solid. Ngayon, ang kailangan ninyo sa ating solid determination ay dadami. Kanina, standard liquid at sample liquid lang. Ngayon, 3 na ang variables or 4. Mass of picnometer, mass of sample plus picnometer, mass of picnometer plus mass of immersion liquid, and mass of picnometer plus sample plus immersion liquid. Magkakaiba po ito ha. Let us differentiate. Okay? Mass of picnometer, picnometer lang. Mukha siyang titi, pero okay lang yan. Ganyan talaga yung tsura niya. Dapat pala hindi ka nalagyan ganun. Okay. Picnometer lang. Intindihan. Mass plus picnometer. Mass of sample liquid plus picnometer is ilalagay nyo na yung picnometer nyo plus sample. Okay? Naintindihan pa so far? Bago yung sunod, mass of picnometer plus sample plus immersion liquid or liquid for short is dinalagay niyo yung sample sa loob. Pupunuin nyo ngayon up to 50 ml ng tubig. Kailangan nyo pa rin ng liquid to fill the picnometer. Okay? You're going to fill it with your sample liquid or any immersion liquid. Naintindihan po ba?
Yes po, sir.
May isa pa. May isa
Yes
pa.
po.
Yes po.
And the final one is tatanggalin nyo ulit or ibububo ninyo yung lahat ng contents. Kumbaga, i-empty nyo yung contents lahat. And you're going to get only picnometer plus liquid. Naintindihan? So, yung process, empty picnometer, weigh. Picnometer, lagyan ng solid, weigh. Picnometer na may solid, punuin nyo gamit ng sample liquid or any liquid, weigh ulit. Tapon lahat, linisin, tuyuin, punuin ng picnometer plus liquid. Okay? Ngayon, naintindihan? Klaro pa so far? Klaro pa? Medyo mahaba ang formula ng solids. Klaro po ba?
Yes po,
Yes
sir.
po.
Okay. Ngayon, sa taas, madali lang. Ang formula ng sa taas ay weight of sample. weight of mass, sample plus peak minus weight of peak. Okay, next, sa baba medyo mas mahaba. Weight of liquid plus peak minus weight of liquid, burahin natin, peak minus weight of sample plus liquid plus peak minus weight of peak. Ay, wait, sorry. Sorry, mali. Weight of sample plus liquid plus peak minus weight of peak. Mahaba talaga siya, wait lang. Hindi siya kasha. Yan. Okay. Mahaba yung baba. So yung taas is weight of sample plus peak minus weight of peak. Sa baba, weight of liquid plus peak minus weight of peak minus, isang buo to ha. Isang buo tong part na to. So it's actually 3 parts. 1, 2, 3. Weight of sample plus liquid plus peak minus weight of peak. Then weight of sample plus peak minus weight of pick. Okay? Now, if you want the more condensed version, simply remove all weight of pick. Pero, kailangan computing nyo muna yung bawat value nun. So, weight of sample liquid minus weight of liquid plus sample minus weight of sample. Okay, yan yung condensed version. Okay? Yung sinulat ko sa taas, mahaba lang yun kasi lagi nating mina-minus yung weight ng pick na nyo. Weight of pick, weight of pick, weight of pick, weight of pick. Pero, if you prepare the weights of the sample, the liquid plus sample ahead of time, madadali ang inyong computation. Naintindihan po ba?
Yes po.
Yes, po.
Okay, so ang tip ko sa inyo is i-process nyo muna yung data. Nakopya yung formula, babalik tayo sa sample problem. Nakopya yung data? Nakopya yung formula?
Yes, po.
Yes po.
Okay. So, what I advise you to do is to process all this data first. So, you can get the weight of sample by simply subtracting the weight na mass of picnometer. Lahat kasi ito may mass ng picnometer. Okay? Kaya siya may mass of picnometer sa experiment, laging kasama yung mass ng picnometer. Kaya kailangan i-subtract nyo muna. So, let's process this data. So, ano ang weight ng sample natin? Anong weight ng ating immersion liquid? At ano ang ating sample plus immersion liquid? So, it's lahat ay minus 10.854. Subtract. Naku po. So, the mass of sample is 1.1862. Pareho po ba nakukuha natin?
Yes, sir.
Okay. $8.0206. $8.492. Para tayo na nakuha data. Para tayo nakuha data. Hello, okay po ba? Nakuha niyo rin yung nakuha ko sa screen?
Yes po.
Okay, now let's apply the formula. Weight of sample minus weight of liquid weight of liquid plus sample minus weight of sample. Okay, so ating weight of sample is 1.1862. Weight of liquid natin is 8.0206 minus weight of sample plus immersion liquid 8.492 minus 1.1862 times specific gravity 0.802. Okay, so compute. Or kung may sagot na kayo, sabihin nyo na. $1.33. Dapat water na lang ginamit. Yep, tama. Tama yun sa Excel, tsaka tama yun sa Calc mo. Double check pala dapat ako nag-Excel. Ang ginawa ko ay... Kung gusto nyo makita yung paano ko kinumpute. Baka nagkamali lang tayo sa order of operations. Nakuha na ng iba yung 1.3309?
Yes po. Yes po.
Okay, sige. Next problem tayo. Yung pala, may sagot. Hindi ako nag-compute. May sagot pala sa sunod na slide. Next. A sample liquid in a picnometer weighed 20.765 grams. The mass of the dry picnometer was 11.677 grams. If mineral oil filled the picnometer and the picnometer weighed 22.315 grams, what is the relative density of the liquid? Okay. Specific gravity of mineral oil is 0.905. Please take note that specific gravity and relative density can be used interchangeably. Pag specific gravity, usually we use it na by default, ang ating standard ay water. But for in this case, na ating standard liquid ay mineral oil, pwede rin siyang itawag na relative density because you're comparing the density of a sample and the density of another sample. So specific gravity is also relative density because you're comparing the sample to water. So something na about naming lang naman. Okay. Okay, so try this one. Dali lang yan kasi liquid lang yan. Wow. So 9.088. Wala dito. Wait naman. Kasi anong bagong catch up. Bobo. Bobo ulit. Were you able to get the same answer? 0.773?
Yes po, sir.
Yes po.
Yes po.
Yes po.
Okay.
Yes po.
Okay. So, madali lang pag liquid at liquid. If yung calculator nyo is parang ganito, na naglalabas ay fractions, you can actually change it. Gawin yung math ay or line. 3 divided by 2. Dapat siya 0.7. Para decimal lang lalabas agad. Hindi kaya pipindot ng SD. Okay, next. Okay, this one. Kaya niya. Sa akin yun lang. Okay, yan ang density ng ating crystal. Next. Okay. Okay. Go.
Sir, na-dissolve po ba siya dun sa water?
Yes, that is the correct answer. The correct answer is you cannot compute for this problem. Kaya kita nyo hindi ako nagsosolve. So, mag-ingat kayo sa tanong na to. Baka lumabas. Pag na-dissolve yung inyong crystal or inyong powder dun sa picnometer, hindi nyo na madidetermine ang kanyang volume kasi humalo na siya sa liquid completely. So in this case, if you proceeded to calculations, itong makukuha nyo. But due to the wrong method, dapat insoluble yung ating crystal or powder bago kayo mag-proceed. Kasi kung nag-proceed kayo, mali ang makukuha nyo, sure yun. Kasi mangyayari, dun sa baba, kung tinuloy nyo at experimental weight of liquid minus weight of liquid plus sample, ito ay magiging equal. Kasi na-dissolve yung sample pupunuin mo lagi ng punuan. So example siya ay 12 minus, bago may weight of sample ka sa ibabaw na 2 over 0. Mangyayari, undefined. So, mali talaga yung procedure. Okay, ingat. Good job on detecting that. Next. Okay, kaya yan. Ay, 2, 4, 4, 2. Hindi ka mailipat ng screen. Tama. 13 point. Kuha niyo po ang sagot.
Yes po.
Yes po.
Okay. Oras na. Go. Okay, so let's continue with our lecture. Okay, so for the last part of our prelim grading period, we're going to cover a review on our solutions. So it's a review because you have already taken this in your quality control 1, and hopefully gamay nyo na siya by heart, kaya dapat madali na lang to sa inyo. So kaya bakit nyo siya kailangan ay dahil sa next part sa midterms natin, we will be dealing with properties of solutions, and basically yung concentrations will play a big part in your second midterm grading period for our FEFARM. Okay, so let's start with what is a mole. So what is a mole? So basically, a mole is a certain number of something. Particularly its number of particles. And this mole is actually based on our Avogadro's number, which is 0.022 times 10 to the 23rd x. Yung x, pwedeng molecules, pwedeng particles, pwedeng atoms, whatever you want it to be. Just make sure, just remember that a mole is a unit to denote a certain number of particles as molecules and atoms. So you may want to imagine moles as something like a dozen. So if 1 dozen is 12 pieces, 1 mole is 6.023 times 10 to the 23rd, or 6.022 times 10 to the 22 particles. Okay, now moles on its own is not particularly useful. However, when we combine moles and molar mass, we can now get mass. Okay, so to get how many moles of a substance, we must first get its molar mass. Okay, so molar mass, anong gagaling yan? Periodic table or the formula. Take for example, you need to get the molar mass of H2O. 18, if you just know it on the top of your head. But to get the molecular weight of a certain substance, you have to do this. Bilangin nyo kung ilan ng particles or ilan yung elements sa compound. So isang oxygen at 2 hydrogen. Tama po ba?
Yes po, sir.
Ang molecular weight or ang ating molar mass ng oxygen ay 16 gram per mole. Then ang ating hydrogen ay 1 gram per mole. Since dalawa siya, 2 times 1 is 2. 16. 2. Molecular weight ng water ay 18 gram per mole. Now, ang convenient or bakit useful ang moles is we can convert grams to moles and back. Okay, so if you want to convert grams to moles, simply divide by molar weight. Okay, molar weight is gram per mole. Magkakancel yan, you will get mole. If you want to get the number of moles, or if you want to get the number of grams, example moles, multiply it by molar weight. Magkakancel ang moles and you will have grams. Okay, we do not usually deal with example 44 atoms, 44 elements. No, masyadong madami ang particles to there's a substantial number of particles to have any significant weight in terms of something holdable like in grams. So that is why we use mole and molar mass to interconvert grams and the number of particles. Tanda po ang conversion ng gram to mole.
Yes po, sir.
Okay, tanda niyo yan. Next, let's have a sample. What is the weight of 1 mole of oxygen? Di ba 17? Di 35. 17 ang kanyang atomic number. 35 at ang potassium. Okay, solve. Practical review lang to. Hindi tayo theoretical. What is the weight of 1 mole of oxygen? Lahat po siya in grams. Nasa taas po yung mga molecular weights. Hello. Ilan po ang weight ng 1 mole of oxygen?
16 po.
16. 1 mole O2 times 16 gram is 1 mole of O2. Cancel this, you have 16 grams. Napakadali, di ba? Next, what is the weight of 15 moles of carbon?
$180 po.
15 moles carbon times 12 grams is 1 mole carbon. 15 times 12, 180. Napakadali, di ba? Dapat nagsosolve din kayo. What is the weight of 3 moles of hydrochloric acid? Ano yun natunog?
108 po.
108. Parang hindi. Laki. Hindi. Joke. 3 moles pala. Let's first get the molecular weight of hydrochloric acid. Mukhang tama yung iyo. 3 moles pala. Okay, hydrochloric acid is HCl. It is made out of 1 part chlorine, then 1 part of hydrogen. 35. Hydrogen is 1. 36. So 36 grams. 36 ang kanyang molecular weight. So 3 moles times 36 gram per mole, you will get 100. Ano nga? 108. 108 grams. Very good. Next, last for this round. What is the weight of 5 moles, nabura ko, of potassium permanganate?
790 grams po.
Ano pa? Anong molecular weight mass muna ng potassium permanganate? KMNO4.
158 po.
158. So, dun sa hindi alam kung saan nakuha ang weight ng potassium permanganate. Manganese ay 55. Potassium ay 39. So, 4 times 16 is 64. Doon susulat 64, 55, 39. Wow, mali. 64 plus. 158 ang molecular weight ng potassium permanganate. Then multiply nyo sa 5. 5 moles times 158 gram per mole. 790. Naintindihan po? Nakukuha? Okay. Okay, reverse. Pabaliktad naman. How many moles of carbon are there in 12 grams of carbon?
One mole po.
1. Kasi ang carbon ay 12. Nitrogen na yan, no? How many moles of potassium nitrate are there in 2 pounds of potassium nitrate? Wala kayong takas. Babalik at babalik din di yan. Remember class that grams lang ang nagana sa moles. So kailangan nyo muna mag-convert sa grams. 9 moles. $10.2 nakuha ko. 2 times 454. 10.2 talaga. 3 times 12, 36. Ah, mali. Mali. Mali ang compute ko. Hindi dapat 12. Dapat 16. Three times 12. 3 times 16. Dapat. 48. 48 plus 14 plus 39. 101. 2.2 times 4.4. 9. 8.99. Daga nagkakamali sa oxygen. 8.99 ang sagot. Okay, how many moles are of ferrosulfate are there in 20 tablets of ferrosulfate if every tablet contains 500 milligrams of ferrosulfate? Sulfur pala. 30 tong sulfur. Do you have an answer? Ano po? Okay. 0.07. Okay, so that's how you get the reverse from moles to grams to moles. Okay. Now next we have units of concentrations using moles. So dati naka-grams per liter tayo, but for solutions, particular in chemistry, we tend to use concentration using moles. So first we have molarity. It is also known as molar concentration. It is an expression of substance concentration. It is defined as the amount of moles per liter solution. A 1 molar solution is 1 mole per liter. And the symbol for molarity is capital M for mole. Capital MOL. Okay. Prefer natin is capital M. Huwag kayong mag-small letter m. Small letter m is moles, not molarity. Okay? Tandaan, moles per liter solution. Always in liters. If your volume is not in liters, convert it to liters first before getting molarity. Okay, sample problems. If a liter of solution had 3 moles of sodium bicarbonate, what is the concentration of the solution in molarity? What is the solution concentration of solution 1? Three. Kasi 3, 1 liter. 3 moles over 1 liter equals 3 mole per liter or 3 molar. Napakadali, di ba? Wala, sinulat ko lang yung nasa taas para guluhin kayo. Nagulo naman kayo. Sunod, if 15 moles of aspirin was dissolved in a gallon of water, what is the molar concentration of the solution?
8.4, sir.
3.4. Let's check.
8.4.
8.4.
Hindi pala ako, sir. 3.96. 1 lang nasa.
3. Tama. 3.96. Nagduda ako sa sarili ko sa ulo ng mga units. 3.96. Okay? Ito lang na sinabi ko kanina, kapag hindi liters yung inyong volume, convert it to liters first. Okay? Kung hindi pa rin kayo marunong mag-convert or hindi nyo sa ulo yung conversion table, kailangan nyo mag-saulo ulit. Next. If 0.7 moles of nitric acid is admixed with 2 quarts of water, what is the molarity of solution? Wait lang. Oops. Joke lang. Teka. Any answer? Hint. 0.7. Convert ko muna ang quarts. 0.396 mole. Okay. Saan ka nagkamali? Conversion?
Nakalimutan ko po.
Okay. Ingat. Okay. Sige. Okay na po. Next. Harder. If 2 grams of sodium hydroxide was dissolved in 5 liters of solution, what is the molar concentration of that solution? May sagot na po sa number 1?
Sir, 0.1 po.
0.1. Zero 0.1 molar solution. Okay, next. If 23.65 grams of potassium permanganate was dissolved in 2 gallons of water, what would be the resulting molar concentration of the solution? Glow map.
Sir, 0.02 po ba yung sagot?
Hindi ko alam. Hindi ko nakakompute. Wait lang. Times 4. 48. 39 plus 55 plus 48. Parang mali. 16 times 4. 158. Molecular weight ng potassium permanganate. So 23.65 grams times 158 gram per mole over 2 gallons. 1 gal, 3.785 liters. Yan ang sagot mo?
0.02 po.
Okay, 0.02. Okay. Sige, yung dalawa, gawin nyo na lang on your own para may magawa kayo sa inyo. Next. After molarity, you now have normality. Okay. So, normality is an expression of concentration using the gram equivalent weight over a liter solution. Gram equivalent weight. The symbol for normality is N. Gram equivalent weight is determined by the amount of an ion that reacts, which changes depending on the reaction. So H ang tawag doon, or the factor. H is called our factor, and gram equivalent weight basically is moles times H. So gram equivalent weight is moles times H, which is the factor. If factor is the number of of hydrogen ions or hydroxide ions in a substance. Naintindihan? Familiar sa normality?
Yes po.
Okay.
Yes po.
So another form of the formula is molarity times H. Kasi moles times H equals over liter equals normality. And ito molarity yan. So moles times H equals normality. Napakadali, di ba? Okay, ngayon, marunong kayong humanap ng H. Ano ang H factor sa hydrochloric acid?
1 po.
1. Sa sulfuric acid? 2. Sa phosphoric acid? P. 3. Okay. Dito.
Po.
Hindi. 1 lang. Remember that H is for ions. Hindi porket may nakita kayong H, yun na yun. So in this case, this is your dextrose. This is your dextrose or plain sugar. So walang ions dyan. Parang naging formula lang siya na nagkataon na may hydrogen. So almost all organic compounds have hydrogen. Paano nyo malalaman kung bibilangin nyo yung H? Nasa unahan dapat siya ng formula. Okay. So katulad nito, wala siya sa una. Hindi siya acid. 1 siya. Pag hindi siya 2, hindi siya 3, 1 siya. Walang 0 na H factor, ha? Naintindihan? Okay. Alam niyo, pang 5 batch na kayo na nauuto ko sa ganyan. Kaya mag-alala. Hindi kayong una. So same goes for hydroxide. Anong H value dito?
1 po.
Okay. How about This one. This one. Three. Bibilangin nyo lang kung ilan yung hydroxide. Ngayon, ang problema ay pag hindi nyo alam. Example, itong sinulat namin. Kung hindi mo alam na Al plus 3 pala yun, hindi mo alam na ganito, hindi mo malalaman na tatlo yung hydroxide ions. Okay? So, paano nyo malalaman? Wala, sa ulo niyo. Dapat sa ulo niyo yung common ions ng iba't ibang bases and our different bases and acids. Okay. Okay. So, first one. If 2 grams of silver chloride was dissolved in a liter of strong iodine solution, what would be the normality of the solution in terms of silver chloride? Sorry. Answer? Zero point zero ano? 0.01. Silver chloride is 35 plus 108. So that is 143? 143 gram per mole times 2. Sorry, divided by 2. That is 0.0139 divided by 1 liter yung solution. Ano yung H value? 1. Remember that if hindi siya acid, hindi siya base, 1. Okay? So the normality is similar to the molarity, which is 0.139 or 0.01. Next, if 5 moles of aluminum hydroxide was put in 2 liters of strong acid solution, what would be the normality of the solution? Huh? 7.5. Kasi 5 moles times ang factor natin ay 3. 3 over 2 liters. 15 over 2, 7.5. Next. Madali po ba? Last question for this slide. What is the normality of 0.125 molar solution of magnesium hydroxide? 0.25. Remember that normality can equal to molarity times H. Since may molarity ka na, 0.125. Multiply mo lang sa H, which is 2 kasi magnesium hydroxide, 0.250 normal solution. Okay. Ang tawag sa solutions natin ay 1 molar, 2 molar. Pag normal, 1 normal, 2 normal. Okay. The third value or the third unit using molarity is molality. Molality is the number of moles divided by the weight in kilograms of the solvent. So, kailangan mong hanapin ang weight ng pinagdisolvan niya. The symbol for molality is the small letter M. It is rarely used in compared to normality and molarity. However, in our solutions later on, especially in our one of our colligative properties, we will be using molality. So, dapat alam nyo rin yon. So, molality, number of moles over kilogram solvent. Ang mahirap lang naman dito usually class ay kilogram solvent. So, kung siya ay liquid, usually that is in liters or ml. Kailangan nyo i-convert to grams or kilograms. Paano nyo i-convert? Ano gagamitin nyo?
Specific gravity po.
Specific gravity or density. Okay. So, kapag hindi binigay ang weight ng solvent, ibibigay ay spec grav. Or, kapag binigay ay water, spec grav 1. Naintindihan? Okay. Yan, wala akong sample problem for that. Okay. Any questions regarding our solutions? Okay. So, that is the end of our lecture series for today.